Welcome to Quiet Learning. In this video, we will slowly explore how global positioning system technology determines location positions on Earth. There is nothing you need to do while listening. You do not need to concentrate or memorize details. You can simply listen and rest. We will move through each step deliberately, one process at a time, following the path from satellites in orbit to a position quietly calculated on the ground. Let us begin. GPS systems begin far above the Earth. A collection of satellites orbits the planet at high altitude, moving in carefully calculated paths. These satellites are distributed so that several are always visible from any location on the surface. Each satellite follows its unique, predictable orbit, maintained through continuous tracking and periodic adjustment. Their role is not to observe the Earth, but to transmit information continuously. Each GPS satellite carries multiple atomic clocks. These clocks measure time with extreme accuracy, drifting by only fractions of a second over long periods. Accurate timekeeping is essential, because GPS relies on measuring how long it takes a signal to travel between points. Every satellite broadcasts the exact time each signal is sent, along with information describing its current orbital position. The signals transmitted by GPS satellites are low-power radio waves. They travel at the speed of light, spreading outward through space and the atmosphere. These signals pass through clouds, weather, and most non-metallic materials, reaching receivers on the ground with minimal interference. The signal patterns are simple and repetitive, designed to be recognized and measured precisely. A GPS receiver, such as one found in a phone or navigation device, listens for signals from multiple satellites at the same time. When a signal arrives, the receiver compares the transmitted time with its own internal clock. The difference between these times indicates how long the signal has been traveling. Using the known speed of light, this travel time is converted into a distance measurement. Distance measurements alone are not enough to determine a receiver's position. The receiver uses signals from several satellites simultaneously. Each distance defines a sphere around a satellite's position. Where these spheres intersect, the receiver calculates its location. This geometric process is known as trilateration. At least 4 satellites are used to determine latitude, longitude, altitude, and to correct small timing errors in the receiver's internal clock. Several small sources of error are continuously corrected. Signal delays caused by the atmosphere are estimated and compensated for. Minor variations in satellite orbits and clock behavior are accounted for using updated data. As the receiver continues to operate, it refines its position estimate, producing a stable and consistent result. These adjustments occur quietly and automatically. Once the position has been calculated, the receiver converts numerical coordinates into useful information for the user. Using a map overlay with known coordinates built in, the receiver can match the coordinates calculated to show a location icon. If the map also has roadways and routing information, it can also offer navigation directions for driving or walking. The calculation repeats regularly, allowing smooth tracking of movement over time. The GPS network itself is monitored and maintained by ground control stations. Satellite health, orbital accuracy, and clock performance are observed continuously. Corrections and updates are transmitted as needed to maintain reliability. Redundant systems ensure continued operation even if individual components experience failure. This has been a slow, measured explanation of how GPS systems work, from precise timekeeping in orbit, through radio signal transmission, to position calculation and directions on the ground. It is a system based on timing, geometry, and careful coordination, operating continuously and quietly while the rest of the world spins.
Thank you for listening.
This is Quiet Learning.